Okay, in the next two examples, we're going to return to the idea of functions. And functions are important because they offer us new ways of conceptualizing problems and also some new notation that helps us to express things in a little bit simpler way than we were able to work with before. So in example 4, we want to write a linear function f with the values f of 0 equals 10. Well, f of 0 equals 10, what that means is when x is equal to 0, y is going to equal 10. So from that we get the point x is 0, y is 10. So again, it's a simple way of saying if you give this function the value 0, it will give you back the value 10. So it's an input-output machine. The input value goes in between the parentheses, so f of 0, and the result is 10. So if that's true, the next part, which says f of 6 equals 34, means that when x is 6, y is 34. And so all I want to do now is write a linear function, which is really no different than writing a linear equation. And I'm going to work the same way I always have. I'm going to label my points x1, y1, from left to right, x2, y2. I am going to find the slope. M is equal to y2 minus y1 over x2 minus x1. So in this case, y2 is 34 minus y1, which is 10, over x2, which is 6, minus x1, which is 0. And so we get 24 over 6, or a slope of 4. Our y-intercept, recalling that the y-intercept is the y-coordinate when x is equal to 0, and so we can see that's our y-intercept right there. It is 10. And now we can construct y equals 4x slope times x plus the y-intercept. And this can also be written as a function as f of x is equal to 4x plus 10. Now, in this case, because we're given the points in using function notation, then we really should write the final result as a function or in function notation. But really, y equals 4x plus 10 and f of x equals 4x plus 10 really mean the same thing. All right, let's go on to example 6, do another one of these. So we're told that g of 0 equals 9. That means that we have the point x is 0, y is 9. G of 8 is equal to 7. Means we have the point 8, comma 7. We label x1, y1, x2, y2. We find the slope. Now this only works, of course, when we know that we're working with a linear function, which we are told that we are. So y2 minus y1 over x2 minus x1. y2 is 7 minus y1 is 9 over x2 is 8 minus 0. So we end up with a negative 2 over 8, which simplifies to negative 1/4. The y-intercept is the y value when x is 0. And so there it is right there. It's 9. B is equal to 9. Put the pieces together. Y is equal to negative 1/4 x plus 9, or f of x is equal to negative 1/4 x plus 9. And there we have it. All right, after this we're going to go on to see how we can use functions to solve some real-world problems. All right, So example 5, excluding hydropower, U.S. power plants used renewable energy sources to generate 105 million megawatt hours of electricity in 2007. Alright, so what we have here is in 2007 we have 105 million megawatt hours, and we'll abbreviate that. Then in 2012, that number had risen to 219 million megawatt hours. What we want to do is we're going to assume, again, that there is a linear relationship here, that the number of million megawatt hours is increasing in a linear fashion. So we want to write a linear model that represents the number of megawatt hours generated by non-hydropower renewable energy sources as a function of the number of years since 2007. And then we want to use the model to predict the number of megawatt hours that will be generated in 2017. So I'm just going to make a quick table here. And instead of using years, we're going to call this X, and we can say the other one is Y, or we can say f of x. Either one is fine. Instead of using 2007, we want the number of years since 2007. And since 2007 is 0 years since 2007, our x coordinate is going to be 0, y will be 105. 2012 is 5 years from 2007, and 219 million megawatt hours there. Now later on we're going to actually use this for 2017, so that would be 10 years, and we want to calculate what that value would be. Alright, so I do have 2 points here. As usual, I'm going to label them x1, y1, x2, y2. And I'm going to calculate the slope. M is equal to y2 minus y1 over x2 minus x1. My y2 value, 219, minus y1 value, 105, over x2, which is 5, minus x1, which is 0. And we're going to end up with 114 divided by 5. Now in this case, it's okay if we use a decimal value here, because we're not going to count up 114 and over 5. So we just have 22.8. Now, our y-intercept, recall, is the y value when x is 0. And so our y-intercept here is going to be 105. So B is equal to 105. Now we can construct our equation. Again, we can either say y or f of x. Y is equal to 22.8x plus 105. So what this will tell us is, for any year after 2007, this will help us to estimate the number of million megawatt hours of electricity generated from non-hydropower renewable energy sources. And the final thing that we wanted to do here was to figure out what y would be when x is equal to 10. So we're simply going to plug in y is equal to 22.8 times 10 plus 105, and when we do that we get 228 plus 105, which is 333. So therefore, when you are 10 years since 2007, the number of million megawatt hours of electricity generated from non-hydropower renewable energy sources would be 333, or 333 million megawatt hours. So that's how we're going to use linear models, linear functions, linear equations to predict and to forecast what particular values will be. So we'll go on to the next example, which is similar to this one, just to get a little bit more experience with this. Okay, then in problem number 7, we have a similar situation. The corresponding data for electricity generated by hydropower. Oh, by hydropower now, so it's not the non-hydropower. Hydropower is 248 million megawatt hours in 2007. So again, we're going to make a table, and the x values will still be the year since 2007. So we'll have 0 and 248 for the y. And then in 2012, which would be 5 years later, there was 277 million. And all we're asked to do here is to write the linear function. We're not trying to use it in this particular instance to estimate anything. All right, so I'm going to label my points x1, y1, x2, y2. My slope, m is equal to y2 minus y1 over x2 minus x1. y2 is 277 minus y1, which is 248, over x2, which is 5, minus x1, which is 0. And so here we get 29 over 5, which comes out to be 5.8. And what that means is that according to this model, the number of million megawatt hours is increasing at a rate of 5.8 million megawatt hours per year, starting from 2007. The y-intercept, we can see, is the y value when x is equal to 0. So b is equal to 248. And we end up with y is equal to 5.8x plus 248. And so that is our linear model. And that concludes the lesson in Chapter 4, Section 1. So we have constructed equations using either a slope and a y-intercept, a graph, 2 points, or given function values, and we have used these to solve real-world problems or create linear models and to predict or to forecast values based on those models. So we'll stop this video at this point.